today I'm going to talk about finish what I started last time. So last time I was looking at fold, the fold operation, especially on lists. So I was giving you some examples of fold operation, and we ended up on a rather fun note. I was giving you this analogy between how fold works, and I was giving you a cartoon version of fold. So let me start there and work through slightly more complicated version of fold. Okay, so it's slightly more complicated versions of fold, and then move on to the next topic. All right. So to do that, let me draw a picture of what fold operation is on a list. So what does it look like pictorially to do a fold on a list? So you have a list, and you say list dot, let's say, fold left, and you give two arguments. You give an initial value of an accumulator, and you give a function. Okay, and the idea here is you can imagine the accumulator, and I was making this Pac-Man analogy last time, which I thought was rather fun. Maybe some of you actually appreciate it because if you have played Pac-Man. So think of the list as this bunch of elements. Okay, I'm representing them by a dot, and think of this accumulator as the Pac-Man character, and that's going to eat the dot. So the initial value of the accumulator is a small Pac-Man character. Okay, and the function is every time you apply the function, the first argument is the accumulator, the second argument is the element of the list, and you get a new value of the accumulator that's somehow bigger. And now you apply the function again, and then you get a new value of the accumulator. All right, and this is this thing that eats these dots, right, in Pac-Man. So now you get the function again, you feed the old value of the accumulator and the new element in the list, and you get a new value of the accumulator. So you can think of the accumulator as being updated as it moves through the list from left to right with the help of this function, which takes the old accumulator, the current element of the list, and gives you a new accumulator. Okay, and if it's a list of numbers, and this accumulator is initially 0, and the function is a function that adds two numbers, then you get a function that sums up the elements of the list using fold. Another example, if this list is a list of numbers and your accumulator is initially 1 and your function is the multiply function, you get the product of the elements of the list. See that, right? Each time the accumulator.
Before you get too far ahead, you're not recording the lecture.
Oh, I don't need to record the lecture. The room records the lecture for me. Don't worry about it. Yeah, thanks. Good. So everyone okay with this? All right. What happens? So we can do some more fancy stuff. So last lecture we saw if the list was a list of string, and this accumulator started with the empty string, and this function was take the old accumulator, put a comma after it, and then add the element. So concatenate the old accumulator, comma, then the element, then you get this comma separated listing of all the elements in the list. So you take all the elements in the list, which are strings, you concatenate them all and put a comma in between. There's also a comma up front, which we can take care of later, but you see how this is going, right? So different values of the accumulator and different values of this function are producing different things for you. Okay, so let me give you a new case then. Okay, so what if my list, let's say it's a list of numbers. Okay, so think through this. My list is a list of numbers. My initial accumulator is the empty list. Okay, so it's the empty list. I'm just going to write it like that. So my accumulator is now a list. Okay, and this function is like this. So this function takes, so let me move this whole thing if I can. Hold on. So this function takes an accumulator, which is a list, the current accumulator list, and it takes the new element, and what it does is it pushes the element in front of the accumulator list. So it pushes the element in front of the old accumulator to produce the new accumulator. So your accumulator is a list. Okay, is there a question? Yeah. Okay, go ahead. Yes, we will be able to combine these types of functions, right? You can always apply a fold and then another fold and then you can do something else, right? So you can always combine these functions, like you can apply a fold and a map and a filter. In fact, the next assignment is a little bit about that. We will look at, what are cases where you can combine these functions to get some stuff done for you. Okay? All right. So let's go back to this case. So my list is a list of numbers. My accumulator itself is a list. Okay, so my accumulator itself is a list and it starts out as the empty list. Okay, and every time you process an element, the function does the following. It takes the current accumulator, it takes the new element and puts that element up front, in front of the current accumulator. So what does this fold function do? Can we imagine in our heads what this fold function does? So again, let me draw a picture now, but now let me actually put a list. Let me put a proper list of numbers like 1, 2, 5, 8, 15. So this is my list of numbers, okay? And it has 1, 2, 3, 4, 5 elements, and that's my 8. That's an 8. All right? And my accumulator is initially the empty accumulator, okay? And my initial element that is going to be processed is the element 1, the very first element in the list, in fold left. So now what happens? This function, remember, the function that I have takes the current element and puts it in front of this list. Okay, so it puts it in front of this list. So the new list is going to be the list with just 1. Okay, now comes the second element in the list, which is going to be the element 2. Then function is applied and the new list is going to be what is this new list going to be? Not 1, 2, 2, 1, because you're putting the element in front of the list, okay? And that's important. Now you see what's going to happen with this function. Okay, so let's do one more step and then tell me what is this function doing. So now comes 5 and then 5 gets put in front. You get 5, 2, 1. So if this process is allowed to finish, what is the return value of this application? What's the return value of this application? It reverses the list. You see that? Okay. So now we are getting to more interesting cases where your accumulator can be a list. Your accumulator can be some fancy thing. So let me show you how to do that. Okay. So let's go back to Scala. Okay. Meantime, let's see reverse. Yeah. So a lot of people got it. Excellent. So let's go back to Scala and let's see what happens. How do we write such a function, right? And so let me point out a few things when you write such a function. So we can say define reverse list of numbers, returns a list of numbers, and you can say something like this, list dot fold left. Now I'm going to do something important. After the fold left, I'm going to put this square bracket. And then I'm going to say list of int. And why is this? So it turns out fold left in Scala is not a single function. It's a class of polymorphic functions, one for each type of accumulator. So here, inside these square brackets, I put the type of the accumulator. So I'm telling you that the type of the accumulator is a list. Previously, I had not done this because previously Scala has type inference and Scala can figure this out to some extent. The moment you start building fancy types of accumulators, you want to make sure that you tell Scala what is the type of accumulator. So here you put the type of the accumulator and you put it in square brackets. Okay. Here the type of the accumulator is a list, so you put list of int. Next comes the initial value of the accumulator, which is nil. Okay. Last comes the anonymous function. So you can say the anonymous function takes an accumulator, which I know secretly is a list, takes an element and puts the element in front of the accumulator. Okay? And so that's the way you would write reverse list. So then if you say reverse list, a list of 2, 1, 3, 2, 6, 7, 8, you would get the reverse of the list as you would expect. Now obviously there is an easier way. You can always say list.reverse in Scala, and that reverses the list. Internally it does a similar thing. It does this fold. Okay so far? So this is interesting, right? So let me give you one more example of a slightly more fancier fold. Okay, so here is another example. So here I want to define a function called flatten. Okay, and let me tell you what I want flatten to do. So flatten is a function that operates on lists with lists inside them. So suppose I have a list and the elements of this function are also lists. So I want inside the list I have a list of 1, 2, I have a list of 5, 6, 4, 5, I have a list of -2, -3, -1, maybe I even have an empty list. So this is a list of lists. Okay, it's a list. Inside the list there is a list of numbers. And in flatten, what I want to do is I want to take the union of all the internal lists. So if this is the input, I want the output to be this list of 1, 2, 4, 5, -2, -3, -1. Okay. So I want to take all the inner lists, break them down, and build one big list which has all the numbers in all the lists. Okay, and this is called flatten. This function is called flattening a list. It exists in Scala. You do have a flatten function. I want you to try and write this flatten function as a fold. Good? I want you to write it as a fold. How would you do it? Okay? So when you approach a problem like this, so I want to write flatten using fold. So there are some questions you want to answer. What type of accumulator do you want? So remember, we are going to iterate through the input list. The question is, what type of accumulator? Okay, question. It's going to be, no, it will be a single fold. So I want to do a single fold on the input list, which produces the output list. Okay, so in fact, let me help you a little bit by writing the type of this function. What would be the type of this function? This function, let's call it flatten. Input, give me a second, is a list of numbers, and the output I want it to be a list of numbers. So this is what I want. Question. Would the accumulator be a list? Perfect. The accumulator would be a list, right? And that's the list that's going to produce the output. So what's the type of accumulator we want to keep? It's a list, specifically a list of numbers. Very good. Now, what is the initial value of this accumulator? Empty list, right? Very, very naturally. So let's call it nil. And what does the function for fold need to do? So remember, the function in fold takes the current accumulator, which is a list, takes an element of the list that you're processing, which is a list, and needs to do something. Question. Concat. That's called concat. Concat. Yes, absolutely. Append with plus plus, which is we call it the concat operator in there are all these names. Okay, we use append in Python. We use append to tack an element onto the end of a list. We use cons to tack an element on the beginning of a list, and we use concatenation to merge two lists together into one list. Good, very good. You got it. Right? So the function fold needs to do this plus plus operator. That's all it is. Okay? Ready to write it? Let's write it. Okay? So this is going to be input list dot fold left. Okay? And let me write down the type of the fold. This is going to be important. Let me write down the type of the fold. So this is going to be list of int. Okay? So let's do that. And then let's start with nil, the initial value, and the function, if you want to be super fancy, just write it like this. It's just the plus plus operator, right? You take the current accumulator, current element, and this. You can write it in multiple ways. You can even write it like this. You can write it as an anonymous function. You say accumulator and element goes to accumulator plus plus element. Okay, very good. Now this will do it. So now you can say flatten, and let's take this input that we had prepared for it. And you see it does more or less what we expect it to do. Well, exactly what we expect it to do. Good. All right. So let me work through one last example. Okay. In this last example, I want to do something more interesting. So I want to index a list out. So what does that mean? So what I want to do is, if you give me a list of 1, 5, 6, 7, 8, 9, 11, I want to create a new list which is going to be, let's say 1, 1, 2, 5, 3, 6, 4, 7, 5, 8, 6, 9. You get this idea, right? So 7, 11. So the idea is, I want to put the index of the element in front and make a pair. Okay, you can start from 0, you can start from 1, but I would like to start from 1. Why not, right? Question you can get. Everyone is okay with this index function? So I want to take a list and I want to number the elements. So 1, 5, 6, 7, 8, 9, 11. The output should be 1, 1, 2, 5, 3, 6, 4, 7, 5, 8, 6, 9, 7, 11. So I want to consecutively number the elements of the list. Question? Okay, let's figure this out. Okay, so again, let's take these 3 questions we need to ask. All right, let's put those questions down. Let's erase these answers because those are no longer the answers we want. Okay, and let me write the type of the function as well before we get started. So what's the input to this function? It's a list of integers. What do you want as an output to this function? Strangely, you want a list of pairs of integers. So now we are getting into complicated stuff. All right. Now let's look at some insights. So give me some insights. Yes, please. No, this is a list of numbers. Here, it's a list of where each element is a pair, and it's a pair of 2 numbers. What is that? Oh, that's a tuple. It's a tuple, right? And I mean, there's a different way of writing it, but it's just a tuple. It's a 2 tuple in this case. Okay. So what kind of accumulator do we want as we are processing this list? What kind of accumulator do we want? Whoa, okay, you got it. So you want to keep two things in your accumulator, right? So one thing you want to keep is this number 1, 2, 3, 4 that keeps going up and up and up and up, right? You want to keep that going, right? The other thing you want is you want the result. You want the partial result to be constructed as you keep going, right? So you want 2 bits of information here. So the accumulator here is going to be a little bit complicated. It's going to be 2 things in the accumulator. The first thing is a number. The second thing is a list of pairs of numbers. Why the second thing is a list of pairs of numbers? This second thing is the partial result, the result that we are constructing for you. In the end, it would become the full result. The first thing is the counter, because if you don't count, you're blind, right? If you're receiving an element 1 and then 5 and then 7, imagine you're fold and you're receiving all these elements. If you don't have a counter, if you don't have a way to keep track, right, you're basically going to not, it's not going to happen, right? It's not going to work for you. So you need that. Good so far? All right. So with those 2, you can do it in this way. All right, how do you do it? So what's the initial value of this accumulator? What's the initial value of the counter you want? In this example, I'm starting with 1, so it should be 1. What's the initial list? No, you would start with the empty list. Okay, you would start with the empty list and the number 1. Remember, the accumulator is updated after you process the first element. So the number 1 will still hit the first element 1. Okay, so it will all work out. Okay, initial result is empty, initial number is 1 because I insisted on starting with 1. If I had said 0, then you would have started with 0. Is this good so far? You're with me? So you have to see this logic, right? Because this is kind of getting complicated, right? But I just want to show you. And then I'll show you a really simple way of doing it as well, which would be fun. Okay, but let me show you the complicated way. All right, using fold. Okay, so what does fun or fold need to do? Many things. So first of all, I would say the function need to increment the accumulator, increment the counter by 1. So the accumulator has 2 parts. One is the counter portion and the other is the portion which is the list. And then add an element with its index to the end of the list part. So I need to do 2 things. So let's get started. So we would do list.fold left. The type of the accumulator has become complicated, so I write it down. And now it's this type. So it's a tuple of 2 things. First thing is an integer. Second thing is a list. The elements of the lists are themselves integers. Okay. Okay, this is going to be kind of the hardest example we will do. Okay. The initial value of the accumulator is 1 and nil, but remember to put it in 2 brackets. One bracket is to hold the argument of the function, and the other bracket is the bracket for the tuple. If you put it in one bracket, it doesn't work. Is that okay? Because it's an argument of a function and the argument is the tuple. Complicated, right? Then comes your anonymous function. Now your anonymous function is going to be so bad that I'm going to use case pattern matching. So I'm going to say, in my anonymous function, I have 2 arguments, my current accumulator and my current element. And then I'm going to case pattern match and say the anonymous function, so let's write this anonymous function here. And this is an example where I wish I had just written it as a named function, but let's just keep carrying since I committed to this. And I'm going to match the accumulator, case match on the accumulator, and I'll match it to case current index and current result list. And then now I'm good. So I need to create a new index, which is index plus 1. I need to create a new result list, which is result list plus plus list of the current index and the element. Okay. So this has updated the result. This has updated the index. And hopefully, if I have done everything correctly, this will work. Oh, I may have written a comment like that. Okay. So now comes all the issues we need to fix. Let's fix all the issues. So nil. Let me write this function better. So let's write this function as update function. Okay, and then let's just define update function separately. That should be it. Okay. Now what? Where did I miss the brackets? Okay. All right. So now it says type mismatch. Found int comma list int of int, required list int of int, but I do have. Oh, yes, thank you. So this returns 2 things. So this returns val final position, thank you, final list equals this, and I just need to return final list. Good. Oh my God, that was a close run thing. Complicated. Okay, I got myself into a real complicated tizzy, so you saw me doing live programming. So what went wrong? something simple went wrong. I'll answer your question in a second. Let me just tell you what went wrong. So when you call this list fold left, it returns two things. It returns a number, which is the final value of the position, and it returns the list which you care about. So what you want is to return that list, not that number, because that number is just the final value of the counter, which you can just ignore. So I could have just ignored it. Not given it a name. It's fine. But what I want to return is the final list. Okay? So I made that mistake, and so I got a type error. Question? Yeah, so this is not the issue. So you can have this, but you need to have two parentheses there. One parenthesis is the argument for fold. The second one is the tuple inside. If you don't do it, then what fold left reads it as two arguments, one and nil. Yes. So update function is going to be returning two things. It's going to be returning a number and a list, and the list itself has pairs of numbers. Okay, so let me try and see if I can. So this is the return value. I didn't write it because Scala is smart enough to figure this out. Okay, I just took a chance on that, but this is what update function does, and I could have written it as an anonymous function too. The mistake was elsewhere. I shouldn't have, I could have just kept going. My code was right. It was just this part of the code that was broken, because the fold left returns two things, the counter, which I don't need, and the list, which I do need, and I cannot return both of them. I have to return just the second part of it, which I did. Okay, question? Okay.
So for some people this keeping is still happening, but then Jacob, I think, is what does the first accumulator and the second accumulator.
Okay, so the question here is, what does the first accumulator and the second accumulator mean? So remember, my function is a complicated function. I want to take a list of numbers and I want to index each element out. So what I need during fold left is I need some extra bit of memory, which is where in the list am I? So I need a counter that tells me exactly what position in the list am I currently seeing. And fold doesn't give me that counter. It only gives me the element of the list. So if a list is laid out, I can say, give me 1, give me 2, give me 3, right? But I need to remember that the 1 was the very start of the list. The 2 was the second element in the list. The 3 was the third element in the list, right? If I don't have that counter, I can't count through and index each element properly. So in my accumulator, I need to carry that counter. And I need to update that counter from one to another. And that's how I keep a counter. Question. So there is a very nice solution that someone just gave me. The question was, do I really need this counter? Because shouldn't the length of the accumulator tell me how many elements I've seen already? Perfect. You could have done that. And then you wouldn't have needed it. I just wanted to show you this trick. Okay? So you could have just looked at the length of the accumulator so far, and you could have figured out how many elements have you processed. Okay? But I could have given you a more complicated function like this, right? I could have said, don't just flatten this list, but also give me an index of which list it came from. So I could have said, flatten and give me a 0 here, and give me a 0 here, because these two came from the 0th list, and give me a 1 here, and give me a 1 here, because these two came from the first list. Right? I could have told you something more crazy, right? In which case that trick wouldn't work, right? You'll have to come up with a different trick, right? So this is a more general solution is all I'm saying. You don't have to do that then. You don't have to rely on that property, but you're right. That's a better way of doing it too. Okay? There's a simpler way. Let me say that and end this topic. The simpler way is to do it like this. So in Scala, you are given some more useful functors. One of the most useful functors is called the zip functor. So what is a zip functor? A zip is basically like this. So if you have two lists, let's say list 1 is list 1, 2, 3. Let's say list 2 is list, let me make it a list of strings, A, B, C. They are of same length, okay? When I say list1.zip list 2, okay, I get something nice. What I get, hold on. Okay, I should have turned off my phone. Sorry about that. I did turn off my phone. Okay, it still comes through. All right. Val. Okay. So when I say zip, it takes these two lists and it combines their elements. It takes the first element of the two lists and makes a tuple. Takes a second element of the two lists and makes a tuple. Third element of the two lists and makes a tuple. Okay, so you see, if I zip list 1 with list 2, I get 1, A, 2, B, 3, C as a new list. So this is a useful functor for combining two lists into a single list, right? And it's literally like a zipper, right? And that's why it's called a zip functor, right? This example, I could have handled it with a zip functor. How would I have done this? So in Scala, you can always write 0 to 10 dot to list, and that creates a list from 0 to 10. Okay? If you said 0 until 10 dot to list, that creates from 0 to 9. Okay? So what I should have done here, I could have done here, is I could have said, instead of doing all of this crazy indexing, instead of doing all of this crazy indexing, I could have simply said val list 1 or list 2 is 1 to list dot length dot to list. So I create a series of numbers from 1 to length of list, and I should have simply said list 2 dot zip list. Okay, I could have just created a series, a range from 1 to n, and I could have just zipped the two together, and that would have done the job for me. Question?
This is from George. He's asking, what if the lists are not equal?
Then zip will fail. So you can try this. What if the lists are not equal in length? Zip will throw an exception. Or not. I am surprised. It's supposed to throw an exception. At least in other languages, it throws an exception. In Scala, it turns out it doesn't throw an exception. It takes the smaller of the two lists and goes until one of the lists runs out. Nice. I didn't know that. Thanks for asking the question. So if the two lists are not of the same length, then zip goes until one of the lists runs out and stops. Okay, which is better, because in other languages, zip will throw an exception if the two lists are not the same length. Okay, so here, if you have zip, then your life is much easier. Let's see, what did I do here? Oh, I have this line which I didn't comment out. Let's comment the old solution. So the new solution works just fine. Okay? Good so far? So I can say index list so you get this list 1, 2, 3, 4 up to 7 and the elements of your list. Okay, so sometimes there is an easy solution and there is a hard solution, but I found that with functors you can completely avoid loops because you have these rich library of things that are useful and you can use them, and like here it would have been a larger loop, right, with a var and an accumulator and concat at the end of the list. Here it's just 2 lines of code and it's very nice, right? You just have 2 lines, very easy to parallelize, all kinds of optimizations get enabled, so that's nice. Okay, so yeah, so that's where I wanted to end this part of the course. I went a little bit longer because of that crazy function I decided to write in a crazy way, but at least it gives you an idea that fold is a very powerful operation. You can do some crazy things with fold, okay? Like carry around an accumulator which can do things like count and all of that.